Hello everyone, this is LeetCode 141, linked list cycle. Given head, which is the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. So, yeah, we follow the next pointer for a specific node, and eventually, if there is a cycle in the linked list, at one point, one of the nodes' next pointer will bring us back to a node we've already visited. So in that case, there is a cycle. And basically, to approach this problem, we're going to use the tortoise and hare algorithm, which is a pointer algorithm. More aptly, it's just a cycle detection algorithm, which makes use of two pointers. So basically, we're going to have a pointer at the start. Well, two pointers. They both point to the head node at first, and one of them is going to be a slow pointer and one is a fast pointer. The slow pointer is going to basically move to the next node, and then the fast pointer is going to move to the next node and then the next node, right? And so basically one pointer is going to be the slow pointer, which just moves, one node. It traverses one node, and then the fast pointer traverses two node every, quote unquote turn. And so eventually, if there is a link, if there's a cycle in the linked list, these two pointers, the slow pointer and the fast pointer, they will meet at some point if there is a cycle. Now, if there's not a cycle, what's going to happen? Well, if there's not a cycle, then the fast pointer eventually is going to reach the end of the linked list, right? So we're going to reach a point eventually where there's no nodes that we can traverse we can't traverse any further in the linked list at some point if there is no cycle. And that's how we can basically find if there's a cycle or not, is either these two nodes or these two pointers, I should say, are going to meet eventually, or they are going to or the fast pointer eventually is going to reach the end of the linked list. Okay, so we'll initialize our slow and fast pointer both to the head node, and then essentially what we're going to say is, while there is a fast node, while the fast node exists, or fast.next exists, we are going to essentially, first of all, let's move the slow pointer. So slow pointer is going to go to the next pointer, and again, the fast pointer is going to traverse down two nodes. Okay. And at some point, if they are equal, we have to check, right? If they're equal, right? If they meet, then we return true, because there's a cycle in the list. Now, if we exit this while loop, by the way, sorry, I have to move this here, so we're still in the while loop. And if we exit the while loop, that means we didn't return true. So that would be a case where we traverse through the linked list and there's actually not a cycle, in which case we just return false. Okay. Yeah. Pretty simple. This like algorithm, this tortoise and hare algorithm, it shows up on a few problems. There's more problems that deal with cycles and linked lists, and or deals with linked list problems. And you're gonna have to use this algorithm. So yeah, I hope this helps. I don't think this problem's too bad. It's kind of hard to come up with. I think intuitively, if it's your first time you've come across this algorithm, but eventually you are going to run into problems where you have to use this again, and as long as you are aware of it now, shouldn't be too hard to come up with a solution next time you see a harder problem that has to use a cycle, or where you have to find a cycle in a linked list for whatever reason. Okay. Anyways, that's it, and I hope this helped.